Welcome. My name is John Toigo. I've been asked by StarWind Software to attend Microsoft Ignite and to give my perspective for about the next 5 minutes on software-defined storage and the latest evolution in software-defined, which some folks have taken to calling hyper-converged infrastructure. I have about 30 years of background in IT, a lot of the emphasis on storage technology, and I chair the Data Management Institute, which is very concerned about the availability and preservation and protection of data. So this is a subject that's near and dear to my heart. Where is storage going? I think it's a question a lot of us are asking right now. Anyway, if you've been reading the trade press, you know that software-defined storage appeared on the horizon probably about 18 months ago, and it's caught on in a big way. Basically, most of the original ideas were advanced toward do-it-yourselfers, people who are trying to cobble together their own storage infrastructure behind all the virtual servers and virtualized applications that they were developing. And then more recently, we've heard about hyper-converged infrastructure, which is essentially a cobbling together of the server components, the storage components, and that software layer into an appliantized model that becomes sort of an atomic unit of infrastructure technology to simplify the way that it's rolled out and leveraged and optimized by IT planners and administrators. And so for about the next 5 minutes, let's just quickly walk down some of the major developments in that space. First of all, exact definitions of software-defined storage vary depending on the vendor you talk to. I'm not going to spend a lot of time debating the merits of one definition over another. Basically, what they mostly have in common is that they're acknowledging the fact that for many years now, the storage arrays that you bought had on their array controller, which is essentially a motherboard, a variety of value-add software applications that were living down on that array controller. So it was an intelligent system unto itself. It also had a tendency to increase the cost of the storage infrastructure, sometimes dramatically. So there was a lot of thought given to the possibilities of what if we just move all this value-add software from the array controller down here and put it into the server in a software layer. This is a stack depicting a typical virtualization hypervisor stack. You have basically your applications, the user-facing applications are riding above an operating system or a virtualization kernel, and part of that virtualization kernel now is software-defined storage. It's a layer of software that is, again, all of these value-add functions that have been abstracted away from the storage controllers of the expensive arrays. All right, in a nutshell, that is the approach. However, there are different ways to implement the approach. If you look at VMware with vSphere and their new virtual SAN offering, basically they've done what we just described. They've abstracted away all those services off of the hardware on the storage and moved them up into a software-based controller. However, they have put a few extra requirements on that cobble. You need a minimum of 3 nodes of storage and servers so that they can maintain some coherency in the replication that's ongoing between them. You also need identical components in each node, the same flash devices, the same disk devices, etc. Every node needs to be configured identically. Okay, and of course you have to use, in many cases, components that are pre-certified to work with the virtual SAN from VMware. If you don't use their pre-certified components, you run into problems of device driver availability and other kinds of issues. And then the data is synchronized between the various nodes via mirroring, which is done as a function of the software-defined storage layer. Nothing wrong with that, except that it's kind of ironic that VMware has decided that they are not going to include VAAI primitives in their virtual SAN solution, which was their previous way of offloading data replication functions to intelligent array controllers. All right, and then finally, the storage that's created is an isolated island. It can't be accessed or used by workload other than the virtual workload that is handled and managed under VMware. All right, now the alternative, and perhaps you've heard a little bit about this either in the trade press or in the various meetings and seminars that they've had here at Microsoft Ignite, is the Microsoft Clustered Storage Spaces approach. Clustered Storage Spaces is interesting technology. It builds on storage spaces, which were introduced by Microsoft in Windows Server 2012. It enables the provisioning of direct attached SAS storage and internal PCI flash components into an interesting storage infrastructure that can then be replicated behind every Hyper-V server that you're operating. They've abstracted most functionality away from the underlying storage components, but not from SAS. They're still using the SAS protocol and its various functions for managing the implementation of storage bits, if you will. They still require that you use only SAS technology. It's used to lock files and volumes. Also, they're using their proprietary SMB 3.0 protocol in order to provide sharing of the underlying infrastructure, mainly sharing only by other Microsoft Hyper-V installations. Although, unlike VMware, they are a little more politically astute, I guess. They've said, now you can use our storage with you can use it with VMDKs if you want. You just have to convert those virtual machine files from VMware into virtual machine file using the format used by Microsoft, VHD, and then you can store them on our hardware. It's kind of an interesting approach. We could talk about it offline if you want. It's best used as a scale-out file server in most people's minds, but basically it is a repository of storage used primarily for Hyper-V. Now, these kind of were the initial forays of the major hypervisor vendors into the realm of software-defined storage. And do-it-yourselfers were quick to try to cobble together some solutions in their own shops that were based on these technologies, but they found difficulties, again, with finding compatible gear, with finding drivers. There was a high cost associated with a 3-node deployment, which was the minimum number of nodes that would make this thing work. And there was no role in these solutions for legacy infrastructure. So even if you just bought your SAN or your NAS appliance a week ago, it was now deemed legacy and no longer useful in the brave new world of software-defined. And there was, of course, no sharing of this pool of resource that you've created outside the domain of the specific hypervisor. And when you add that all up together with the expense of software licenses, which could run from $8,000 to $16,000 per node in some cases, and then hardware costing almost that much, you could end up with an initial upfront investment of $90,000 just to create a 3-node cluster of a hypervisor dedicated stack. So, enter hyper-converged infrastructure. Hyper-converged infrastructure is a very simple idea. What we do is we take the software-defined storage layer, we take that software, whether it's integral to the hypervisor or it's from a third-party vendor such as StarWind software, and you use it as sort of a middleware glue to tie together the server components with the storage components. And then you ship the whole thing as an appliance that you can then deploy as an atomic unit of technology and scale out by deploying more and more and more of these nodes. It reduces the overall cost and complexity of the deployment, so that's the primary value case for it. Ryan Brown is here from xByte. He's going to talk about this new appliance that they have cobbled together with StarWind. It's based on commodity Dell servers. Just 2 nodes are required to bring up a redundant infrastructure, so you've already cut by at least 33% the cost of the underlying storage infrastructure. And it's pretty easy to scale one of these things up by adding more CPU, more drives, more capacity, or to scale it out by adding additional nodes. Now, these are the boxes. Ryan, I'm going to turn things over to you.
Thanks,
Welcome.
John. So I'm Ryan Brown with xByte Technologies. We've been in the enterprise server space for the past 13 years, and we're one of the largest Dell resellers in the country. So why do we partner with StarWind? We've been hearing all the things that John talked about as far as the problems, the challenges with hyper-convergence. So we partnered with them to bring the hyper-converged to the SMB and to the remote office space. So we took what you'd call a commodity Dell hardware, and we layered on top of that StarWind's virtual SAN software. And we pre-tested that, we pre-configured that to the exact specs of that server. And what that's done is that's given you a true plug-and-play hyper-converged experience to the end user. With that new box, some of the key differentiators is, unlike their competitors, who, as John was saying, take 3 nodes to give you high availability and redundancy, with the StarWind product you only need 2, and Max in a second will go into some of that architecture. Another key differentiator is with the commodity hardware. So with flash storage, you look at the competitors, they'll require flash storage, they may require certain brands of flash storage. With the StarWind software, again, the idea is keeping the costs down. So they've done that by allowing any flash storage or no flash storage at all. It is an optional piece of that. So actually, what we've built together is we've built our solution with edge drives. We want to keep that cost down, but keep performance up. So without further ado, let me bring Max on here from StarWind Software to talk about their architecture.
Hey,
Max.
Thanks, Ryan. Hi, everyone. Max Kolomyeytsev, StarWind Software Product Manager. So, as you see, there is a really interesting solution coming out to the market. Before, it was just software-defined storage. Right now, it's a pre-configured, pre-packaged solution, which starts with just 2 servers. So an ideal scenario for any SMB, any remote office, branch office, which doesn't need all that complex infrastructure in their environment. You may be short on staff to manage your storage, you may be short on staff to manage your virtualization, so why spend extra money on the hardware? Because you can save that money for managing it efficiently. You can save that cost for making it more reliable and highly available. And the idea behind StarWind Virtual SAN is essentially to be a natural part of the hypervisor and provide the best performance ever for your applications, for your virtualization stack. It can be even non-virtualized applications here, like SQL, SAP, Oracle, you name it. And of course support multiple protocols, so it plays well with all the applications in your environment. If it's heterogeneous, if you have some legacy apps using different types of uplinks like SMB, NFS, iSCSI. All this plays well with StarWind. And the configuration is pretty simple. We have 2 servers, and their local storage is being replicated by StarWind Virtual SAN. It's then presented to the same service as a single highly available storage resource. And you put your virtual machines on top of it, you put your applications on top of it. Should any of the nodes fail, everything fails over quickly without any glitch to the customer. And these 2 systems is a starter kit. You can stack these up to 64 nodes or even more. And of course you can upgrade individual components. There is no need to do exactly the same node. You can modify it along with your needs. You can go with bigger units like R720s or you name it. There is a bit more on the technical specifications of these servers. So you can see we have a variety of options here. You can go with just spindles and flash. Depending on that, you get different performance, you get different scalability options. And these 2 systems are the mid-range, and we'll also have a smaller with 2 tower servers for those who don't even have a rack at this point. They may be growing and they just want to put something in their office to work with. And there are of course 2 bigger systems like R720 for really dense VDI deployments or for high performance computing and virtualization. With that, I'd like to thank everyone. I hope it was interesting for you. For more information, there is a set of contacts here. Feel free to contact us if you have any questions. Have a good day.